Core 1, practice paper 6, question number 2. We've got a curve with the equation y equals some function of x, and we're told it passes through this particular coordinate. We're given the f dash of x, in other words the equation for the curve differentiated. We're given that f dash of x is 2x raised to the power third minus 4. We have to find the original function. So the original function, fx, is going to be f dash of x integrated with respect to x. So let's write that down. We have to integrate the expression with respect to x. If the question goes wrong, you could actually get a mark for writing that down, because that shows you understand the mathematics of what needs to be done. But it would be better to then get it right, wouldn't it? So when we integrate, we raise the power, or index, whatever you want to call it, we raise the power by 1, and that will raise that up to 4/3, and we then divide by that new power. Integrating minus 4 will give us minus 4x, and we have to include a constant of integration. So we now know that the function equals this. We can work out the constant of integration if we're told some additional information, and we're told that the curve actually passes through this coordinate of x equals 8, y equals 4. So let's substitute the coordinate into here, which is another way of saying substituting the value of 8 into there. Substituting 8 into the function will give you the answer of 4. So let's substitute 8 into here. Now really I should have tidied up this algebra before I went on, shouldn't I? Let's do that now. Multiply the top and the bottom by 3, and in fact that 2 will cancel with the 4, leaving you with your 2 underneath. You should always simplify algebra without being told to. Always tidy up the algebra, and I should have done that. Anyway, I've done it now, haven't I? Let's substitute our value of 8 into here. Now we need to appreciate this power of 4/3. The bottom is 1/3. 1/3 means cube root. So we need to cube root and raise to the power of 4. The order doesn't matter. Whether we cube root first and then raise to the power of 4, we'll get the same answer if we raise to the power of 4 and cube root. But it's easier finding the cube root first. So let's have a look. We've got 8 is the value of x we're substituting. So first we have to cube root it, and the cube root of 8 is 2. We now raise it to the power of 4, so we get 2 times 2 times 2 times 2. 2 2 is 4, 2 4 is 8, 2 8 is 16. So in fact we've got 3/2 multiplied by 16. Substitute our value of x into there. 4 times 8. That 2 will cancel, give me an 8 there, so it's 3 8s are 24. Yes, I could have gone straight to that line. How many lines of working out you put down is entirely up to you. But it's a non-calculator paper. That's 24, take away 32, so that's minus 8. And a non-calculator paper, add 8 to both sides. It is easy to make silly slips, especially if you talk at the same time as doing the working out. But in the exam you won't be talking, will you? You'll be sitting there lovely and quiet. Beads of perspiration appearing on your forehead. So we can now write down the equation, replacing our value of c. That's question number 2. 4 marks. I would suggest there'll be 2 marks for this integration, the tidy version, rather than leaving it like that. A mark for finding the value of c, and then lastly a mark for actually getting the equation correct. 4 marks. And that question number 2 is from www.mathstutor.biz, and it is the second question from this practice paper number 6. There's the second question. If you want to see this exam paper with the opportunity of working through every question and the opportunity of seeing all of the questions worked out on a DVD with the marking scheme, then visit www.mathstutor.biz and look for Core 1 Mathematics Set 2, because Set 2 contains 3 papers, paper 4, 5 and 6. I'd like to hear from you. Do visit the website. Good luck in your exam, whether you do visit or not.